Hi, it's Paul from howtonetwork.com and 101labs.net. So this is the Cisco CCNA in 60 Days program. The book's on Amazon if you want to grab a copy. It's version 4. Please subscribe to the channel if you want to see all the other videos that we put up. Today's access list, day 29. So access list is one of the toughest subjects for the CCNA. But with lots of practice, you'll actually become quite good at them. So do the usual steps that you need to do every day. Don't skip those, please. So today's access list, wildcard masks, and I think there's 3 labs: standard, extended, and named access lists. All of these things are going to be featured in the exam, I would guess, in some capacity, a lot or just a few, but you need to know them. There's some books will also help you. 101 Labs IP subnetting, the IP subnetting from Zero to Guru book, and there's a 101 Labs for the Cisco CCNA. So without further ado, we'll get into the lesson on the theory of access lists, and then we'll do some labs. Welcome to access list presentation, or one of the first presentations. So access list is one of the toughest areas that network engineers or new network engineers find to study for and apply and troubleshoot. So I'll put it in the same kind of league as subnetting, really. Subnet and access lists are the two toughest things. The other stuff you can kind of get your head around eventually. I think really with access lists, the best way to learn anything is to do some access list labs. And as you try and do the labs, or as you do the labs, you'll find yourself doing troubleshooting, finding what works and what doesn't work, and being able to put the theory into practice. Because you can watch these lectures several times over, but really I don't think it's going to sink in until you start doing some hands-on configuration. So you can consider access lists really like a filter or a traffic cop of the network, where it's deciding what can and can't pass through the router. Now a lot of people think access lists are just there to block traffic or ports, but they can be used for other things, and you've already seen access lists being used in some of the labs. We used access lists for our network address translation. Also handy when you're doing debugging, because if you want to debug a certain type of IP packet, you can use access lists with it just to tailor it down and keep the CPU use on the router as low as possible. So the 3 main types we need to concern ourselves with as a budding Cisco engineer: standard, extended, and named access lists. Standard access lists are the easiest sort, really, because they've got the least amount of possible permutations to put in. So the way the router knows it's a standard access list, unless you're configuring a named version, is the number, and you put in numbers 1 to 99 when you're configuring it. Now the only thing the standard access list can look at is the source of the traffic. It can either look at the source network or the source host address, but that's it. It can't look at what's actually in the packet, what type of protocol. It can't look at where it's destined for either. Now extended is the main sort of access list you'll use as a network engineer. The only shortfall is it filters a lot more, and you've got a lot more granularity, but because of that it actually has a lot more permutations for you to have to put in. So the router knows it's an extended access list because it's numbered 100 to 199, but it can filter, as I said, on a more robust range of services and protocols. The named access lists are the sort of newer type of access list that's available. Fair bit more user friendly, but the drawback is it's got a slightly different way of configuring it as compared to standard and extended. So really it's a third way you've got to learn to configure access lists. So you're giving your access list a name, and then you tell the router if you want it to be a standard or extended access list. So stuff we presume you know when you're configuring your access list really is all of the common port numbers, which we've covered in other lectures, but you really do need to nail down a list of about 15, possibly even 20 port numbers, because you'll get tested on those in the exam. And you won't be able to write your access list either. You need to know how to write the commands, because in the exam you may not be able to. You can use the question mark key, but you can't really fall back on that during the exam. There are unfortunately a set of rules, and in my career as a network engineer I've very rarely found these rules written down. They just tend to be something you learn as you go along, or if you see the rules written down, there's only one or two rules, when in fact for access lists there's a list of several rules that you need to understand. So some common port numbers which you can you can either pause this video, look at the cram guide, or look at other lectures, but you do need to know all of these. Command syntax, yeah, we'll come to this later on, and we're going to be doing some access list labs as well. So rule number 1. You're allowed one access list per interface per direction. I could actually put in brackets as well per protocol, but really we're only concerned with IP now. We used to be tested on IPX and AppleTalk for Cisco exams, but they're not really used anymore. So if you've got a serial interface on the outside, you can have one access list coming in and going out, and one coming in and one going out, and the same for your LAN side as well. You can have one coming in and one outgoing. So I'll come to the reason why that is, but to be honest, you should be able to configure everything you need in one access list on your router. So the router reads the access list very quickly, but it starts at the top and works its way down to the bottom, and it will stop when it reaches a match. It won't look further down your access list to see if there's a better match. So for example, our access list here, we're looking at incoming traffic from 172.16.1.1. First line is a 10, no match. The second line is 192, no match. The third line, we're permitting the entire network 172.16. The router will match that part of the access list and permit the traffic through. The problem is this network engineer has put a deny that 172.16.1.1 network on the bottom of the access list, and they're trying to work out why the traffic's still being permitted. Well, it's because of the rule that the router starts at the top and works its way down and stops when it gets a match. Number 3. There's an invisible, some people say implicit, but anyway, you can't see it, so I say it's invisible, a deny all at the bottom. So imagine you've got an access list that's permitting certain traffic, possibly denying other traffic. The whole idea behind an access list is it denies everything, or denies everything that you tell it that isn't permitted. So it would be a bit strange for an access list to permit everything at the bottom. So we've got incoming traffic 172.20.1.1. So you go through this access list, it doesn't match any of the rules on the access list. Now, as a safety precaution, this implicit denial says, well, you haven't told me to permit this traffic, so I'm going to deny it. The other thing is, which people get stuck on, is the router can't filter traffic that is generated from itself. So an example, we've got an access list on the router, deny traffic to 172.16.1.1. The PC on the inside of the network is pinging a PC on the outside, and it says ping 172.16.1.1. The traffic hits the router, looks it up and says, no, I'm actually blocking that traffic. Now, if via the router you ping the host 172.16.1.1, the router shouldn't inspect its own self-generated traffic. Now, you may find that it doesn't behave in the way I've just said, but this is the general rule on routers. technology changes, iOS changes, and the router models change. But the general rule is if you send a ping out self-generated from the router, then the router won't inspect it itself. Now you can't edit a live access list, so if you've got one configured on your router and it's doing its job on the interface, you can't go in and edit it while it's working. Now this rule applies for standard or extended access lists. It doesn't apply to named access lists, which you can edit. So the way to do it, try this when you're doing a lab, but you need to basically remove the access list from the interface. A lot of people make a mistake and they delete the entire access list of say 20 lines, which doesn't make sense. All you need to do is deactivate it from the interface that the access list is applied, and then what you can do is go into your running config. You could do show run, for example. You copy that access list into Notepad, edit it in Notepad, and then you go back into the router and you reapply the access list and then do a show run. Rule number 6. You can disable the access list on the interface, which is what I mentioned before. So to apply it, if it's access list 101, you type IP access -group 101 in. Why you call it a group and not a list, I don't know. It's just the way the programmers have got this all set up. So in order to disable it, all you do is type that command out with a no in front, and that will stop the access list being processed on the router, but the actual access list will still be held in the router's config. You can use an access list more than once. Some people don't seem to realise this either. If you've got multiple interfaces, you're allowed to use the same access list. You could even use it for your NAT if it fitted in, and to do any debugging. So I've got an example here, 2 different serial interfaces on the same router, and the access list is used at the same time. And keep them short. This actually looks like 2 rules to me. Keep your access list as short and neat as possible, and the most specific rules at the top. So if you've got a particular host that needs to be denied, it goes nearer the top, and then networks further down. So you can see I'm denying a network here, permitting a network at the top, permitting a specific host next down, permitting a network, and denying a host at the bottom. So if you've got a particular host address, you put it closer to the top. So there we go. The reason why we do this is your router access list takes up CPU cycles. So every time it looks at the line, it processes CPU cycles. So if you've got a specific entry, it goes further up the top, and basically your router will consume less CPU cycles, deal with the access list, and then be able to dedicate resources to doing other things. If this access list is referenced regularly, say every second or every few seconds, the router all the time is going to be doing a process from all the way from the top down to the bottom, and then taking an action when it gets to the bottom. Alright, so you're going to hear different things about this. Cisco say to put an extended access list in a different place to a standard access list. That doesn't really stack up, to be honest, because if you put, say, a standard access list close to your LAN side, but the traffic's coming from your wide area network, the router has to bring the packet in. It has to do a routing entry, decide which interface to send it out. Then when it gets to the interface, the access list is inspected and the traffic is dropped. So I always say place the access list as close to the traffic source as possible. Okay, so they're the main rules. Please get these into your head, learn them, do some labs, and then come back and then check the rules again just to confirm that you understand how they all work. Okay, welcome to the next part of the access list series. We're looking at wildcard masks. Only a few slides for this. Wildcard masks are going to be useful when you're configuring networks with OSPF and also when you're configuring access lists. So access lists are basically a set of matching in binary, and although we don't write our access list out in binary, this is how the routers will look at them, and it's in a series of matching the subnet mask with another value and producing another value. So they basically tell the router which bits to match, and we need a quicker way of writing out wildcard masks, obviously, because binary takes too long. So the only rule really you have to remember is the wildcard mask, when you write it out, must hit the value of 255 when you compare it to the subnet mask. So here's one example: the subnet mask 255, 255, 255, 192. When you're writing the wildcard mask, you need to ask yourself, what do I add to this to get to 255? And the values obviously for the first three columns are 0. For the last column, if you add 63 to 192, you get 255. So that's a fairly simple one. Next value, the mask is subnet is 224.0. So your wildcard mask is 0.0.31.255. Again, if you add those values together, you must get to 255. Just another couple of examples. Again, a different type of subnet mask, and the rule is exactly the same: must reach 255. So if you want to match traffic from the 172.20.1.0 network with the mask 255, 255, 224.0, if you want to write out the wildcard mask, it ends in 31.255. So the access list would be access list 1, for example, 172.20.1.0 and then 0.0.31.255. That would match any host in that subnet there. Another straightforward example: 192.200.1.0 with /26 mask. You write out the subnet mask and then the wildcard mask underneath, so you can get to 255, and there's the access list that would match all traffic from that subnet. 10.10.10.0 with a /30 mask this time. One thing you've got to remember when you write out the wildcard mask for a /30 network, which ends in 252, you've only got two hosts. So what a lot of people do, that if you're trying to deny a host in the 10.10.10.4 subnet, you need to write that out with the same wildcard mask. So have a go at that. Do a lab where you're trying to deny hosts in the 10.10.0 network, and then the next subnet up from that is 10.10.10.4, and then the next one is 10.10.10.8, and so on. So you need to specify which hosts, because the router will only deny what you tell it to deny. So in this particular example, you're going to deny hosts 10.1 and 10.2, and this is the wildcard mask that will achieve it. So like anything, have a go, practice some of these on some Cisco routers and have some fun with it. Configuring access lists. So half of the battle is learning the theory and the rules and the ports and the way the commands are all put together, and then obviously how you apply them. And then the second part is actually doing the live configuration on routers. And this is where this presentation comes in. Standard access list, you'll start with the easy way or the easier way of doing it. We're looking at permitting or denying a source network or a source host. So fairly simple. So you see traffic coming into this router. The source is 172.16.1.1. The packet has obviously got a destination in and a port. However, the standard access list can't concern itself with these details, and it isn't designed to do that. It's just designed to look at the source. So if you wanted to deny a certain type of traffic coming from a certain source, then your standard access list wouldn't do the job. So we've got a network here, our router that we control on the far left, and we've got 3 different networks coming across the wide area network. The 172.16 is just a host on the network. We've got a 10.1 network range of addresses, and then we've got another host, 192.168.1.1. So it's just a little example. And say we want to configure a standard access list. We'd go into router config T and then access dash list, then the number, and all of the numbers need to match on the lines of our access list because they're all part of the same access list. We're permitting host 172.16.1.1, we're permitting the 192 host, and we're permitting the network 10.1.0.0. After that, if we apply that access list, the invisible command, the implicit denial, would deny all of the traffic. So extended access lists, we can look at source, destination, ports coming from or where they're going to, protocols and services such as ICMP, and ping is one of the services that uses ICMP. So syntax, just remember in your head you're looking at access list number, permit or deny, what type of service are you permitting or denying, and which port if applicable. So here's an example of an access list. Access list 101, what are we doing? We're denying the service is TCP, and then from and then to. From is an entire network. We could specify a host, but it's a network, the 10.1 network. And we're denying traffic from that network to host 172.30.1.1 if it equals telnet. You can actually type in port numbers in access lists, but the access lists generally on Cisco routers swap it to the name of the service. The next line, this is a different access list it looks like because we're configuring access list 100. You can do that, but obviously as I said earlier, you need to you're only allowed to have one access list per interface per direction. So this could be an access list for another part of the network. So we're permitting TCP traffic from the entire network 10.1 to host 172.30.1.1 equals FTP. The next access list we're permitting all ICMP traffic from anywhere to anywhere. These are just illustrations, by the way. I'm not saying this is what you need to be applying to your network, because I just want you to practice the commands and see how they work together. So this time I've added 3 servers behind our network. The 172.20.1.1 is a mail server, 30.1.1 is a file server, and 172.30.1.1 is a web server. Looks like I've actually got the wrong address. It should have been 172.40.1 but that was a mistake on my part. So we'll look at our access list. So just bear in mind I just put the wrong IP address for that host. Access list 100, permit TCP host, TCP from host 172.16.1.1 to the host 172.20.1.1 equals SMTP. So we're allowing mail from the 172.16 host to the mail server. It stands to reason. Next line on the access list, we're permitting TCP from an entire range on the 10.1 network, and we're permitting it to the FTP host server if it's using the FTP port. The next line, we're permitting TCP from host 192.168.1.1 to the 172.30 host if it equals web traffic. So you can stop the slide for a moment, have a look at the lines of the config. Obviously the web server should have a different IP address in, but the syntax would be exactly the same. Next access list, we're denying ICMP. So instead of TCP or UDP or anything else like that, we're denying ICMP. So any services that use ICMP, such as ping. From anywhere, we can type any, which stands for anywhere, to the 172.20 network. Next line, we're denying TCP from the 10 network to host 172.30.1.1 if they're trying to come in on the telnet port. Next access list, 102, permit TCP from anywhere to host 172.30.1.1 if it's equals FTP. The established keyword you can use on the end of an access list. What this means is it's looking for a response. In the three-way handshake, different flags are set on the packet when it goes out, when it returns, and then when it goes out again. The established flag means that the session was initiated from inside your network. So when you type establish, what it's looking for is it's going to let the traffic back in if you requested the connection to come in through FTP in this example. Named access lists, different syntax, a little bit of a pain really, but they're very useful, and of course you need to know them for the exam anyway. So we've got our same network, IP access dash list, and then we type extended or standard. If you typed a question mark there, it would give you the 2 or 3 choices. So extended or standard, and we have to give it a name. In this instance, I've given it the name block web. They are case sensitive, so when you apply it, you need to get the upper and lower case correct. It will drop into named access list config prompt, and all we need to do is type permit or deny or whatever we want to do. In this instance, we're denying TCP from anywhere to anywhere on port 80. Applying access lists is a little bit of a pain. You can actually apply them to physical ports or interfaces such as your console port or your VTY ports. If you write access list 101 to apply it to an interface, you type the command IP access -group and then the number and then in or out. You can apply it to your telnet lines. If you're doing it to a line such as a console port or VTY lines, you type access-class. Don't know why you do that, but that's just the way the programming has been configured. If you're applying a named access list, then it's IP access -group and then the access list name and then in or out. Welcome to the Standard Access List Lab. We've got quite a basic network here with 2 routers. The 192.168.1 network is in the middle, connecting our wide area network. Dot 1 is on the left on router A, and dot 2 address is on the right of router B. Each router's got a loopback 0 interface just so we can do some testing. Loopback 0 is 10.1.1.1/8 on router B. And there's 172.16.1.1 on router A on the left there. Each router has got a static route, so all are zeros, and then it points to the exit interface for the serial. The reason is if we source a ping, which we will in a moment, from loopback 0 from router B to router A will see source traffic from the 10 network, but it doesn't have a route. We're not operating any routing protocols, so it'll just drop the packet. So it's going to give us false information. So first thing you always do is just test a ping just to make sure your network is working. So I can ping from router A to router B. So router A, what I want to do is deny the 10 network with an access list, and then we'll test it with a ping. So conft, if I type ACC and then tab access list, then I've got a choice of numbers. So access list, because it's a standard access list, it'll need to be from numbers 1 to 99. And then we've got to choose, are we going to permit or deny traffic? Well, we're going to deny. Whoops. you can either deny a host if you type question mark, and I recommend as you do this you always type the question mark and just see what all your options are, because some you'll use, others you use now and again, and some are there but you probably wouldn't realise it because they're very rarely used. So we can deny a host if we just want to deny 10.1.1.1, or we can deny the 10 network just by typing 10.0.0.0. We haven't covered wildcard masks yet. Basically the wildcard mask is the opposite of the subnet mask. So our subnet mask on the loopback 0 and router B is 255. So it's 0.255.255.25. Don't worry about this too much until you've watched the wildcard mask video. The other thing is, remember there's an implicit deny at the end of every access list. So if we don't put in access list 1 permit, and what are we permitting? A network, a host, or anything? Well, we'll permit anything because we don't really care what else works on this lab. So we've added the access list. The other thing is we need to remember is we need to put it somewhere. And as silly as it sounds, the most common mistakes that are made, and I've had to re-record this video actually because I was so busy talking I made the mistake myself, is we need to add this access list somewhere, because the access list needs to be referenced by a NAT pull, or it needs to be referenced by a debug, or it just needs to be applied to an interface or a port. So my interface, my serial, check with your show IP interface brief what yours is. Mine's serial 0/0/0. The way to add it is if you type IP access-group, then the number, and then you choose in or out. Well, we're checking packets coming in. We're not worried about packets going out. So Control and Z. So what we need to do now, in fact, if I do show IP access lists, you'll see our access list is blocking the 10, anything from the 10 network. So 10, and then the 255s mean don't care what comes after. Anything after that we don't care, it's going to be blocked. Permit anything else, and it's been applied to our serial interface. Right, so let's test a ping. If I ping the 172 loopback from router B to router A, it should work. Yep, that's working fine. But if I do an extended ping, if I type ping and then try the same address, yes to extended commands, I don't think the source interface works on Packet Tracer, so I'm going to source it from the actual address 10.1.1.1. Press enter a couple of times, and there you go. The U's mean it's been blocked by the access list. There you go. Type show IP access list again. 5 pings, 5 matches, 1 for each ping packet that was rejected. So you can see that access list is working. If you're feeling a bit adventurous, or you want to come back and change things up, add another loop back and deny a different network. Or what you could do is instead deny a host, and for example you can deny the host 192.168.1.2 from pinging the loopback, but permit everything else. So this time the loopback from router B should be able to ping to the 172 address, but the serial shouldn't. So that's another way of testing out the lab. So have fun with it, play with it, break it, post some questions if you got them, and learn lots of stuff. Welcome to the Extended Access List Lab. Just for ease, we're going to use the same topology as last time. All the same IP addresses and the static route going from router A to B and B to A. So access list, there's a whole bunch of stuff you can deny or permit with these. So I thought perhaps if we go into router A, first thing we can do is go to conft line VTY 0 space question mark, and I've got 15, well 0 to 15. To do a password of Cisco, and you need to type login as well. So what I've just done now is I've enabled Telnet to this router, and if I go to router B, I can test this. Telnet 192.168.1.1. What's the password? Cisco, and I'm into router A, so I can go into enable mode. Oh, I haven't set an enable password, but it doesn't matter. So to get out, Control Shift 6 and then X. So hold down Control and Shift and 6 at the same time, and then the X key. If you press Enter, you've got to be careful. It will it resumes your connection, which I find a bit annoying. But Control 6 X and the type of command or whatever. So there you go. Alright, so router, let's go back to router A. What we'll do is deny Telnet coming in to router B. So conf t IP access list. Now this time it's an extended, so 100. What are we doing? Are we access list. I'm doing a named access list there. Access list 100. Are we permitting or denying? This is how I like to remember it. Access list number, permit or deny, source, destination. Oops. What are we permitting or denying? Well, it's Telnet, so we can deny protocols or services such as ICMP or the whole of IP, which I don't really want to do. We're denying Telnet, which uses TCP. Where are we denying Telnet from? Do we want to deny it from anywhere or a certain host? Well, you can play with these access lists if you've just got doing this on a home rack. Let's deny it from anywhere, and then we've got our destination address. Let's deny it from anywhere to our serial interface, which will let us test it in a bit. Access list 100, deny TCP from anywhere to host 192.168.1.1. The other thing we'll need to say is we'll need to specify the port number. So if type question mark, if you want to specify a port number, it's EQ, which is for equals, and then question mark. There's a few different things to choose from. You've got a limited range here because of the fact it's a router simulator here. Equals 23. In fact, I'll put Telnet. I should be able to put 23 and it would change it to Telnet. So we're denying something here. Remember, there's an implicit deny, so what we need to do is permit anything else. Permit. We can't just write permit anything. We need to say permit what? Permit IP from anywhere to anywhere. And there we go. It's quite a simple access list. We need to apply it to our serial 0. IP access group 100 in. So let's just review with the show IP access lists. We're denying TCP from anywhere to host 192.168.1.1 equals Telnet. So on the Telnet port, we're permitting all other IP traffic. Some people here write permit TCP, NENE, or they'll permit UDP. That isn't correct. You need to write permit IP NENE if you want to permit all other IP traffic. Otherwise, routing protocols will be blocked and all sorts of stuff. Okay, so it's been applied. Let's go on to router B. I just pressed enter, so it's resuming the connection, and it shouldn't work. There you go. connection timed out, remote host not responding. So I can't telnet from A to B, but if I telnet to the loopback, this should work. There you go. So I'm not telnetting. I'm telnetting from A, but I'm not telnetting to 192.168.1.1. I'm telnetting to 172.16.1.1. So the access list is looking, saying, well, this isn't a match, so I'm going to permit this traffic. And I can't go into enable mode, as I said, because there's no password set. So Control-Shift-6, X. So that's proved off the access list. What we can do, if you wish, is do something else with the access list, or get rid of the access list. Conft no access list 100. Oops, no access list 100. So that actually gets rid of the access list. You can do access list 100. We'll configure something different now. So basically we're moving into a second lab. Permit or deny. Well, let's deny. Let's deny ping traffic, ICMP, from anywhere to anywhere. So that's the end. Type question mark. There's other ICMP has all of these packets basically, but we're just going to deny all ICMP. It's echo and should be echo request and echo reply. We cover our pings there. But let's deny ICMP from anywhere to anywhere. Exit. Now access list 100 is actually already applied to our serial interface, or it should be. Yeah. So if I test it now, router B, if I ping 192.168.1.1, ping should be denied, and there you go. So we've done a second access list. I could have added that as a line, a second line on the access list. So there's a whole bunch of stuff you can do, but there's just a couple of ways you can configure access lists. Have a play with it, try different things. The only problem you have is when you're doing access list, it's harder because we don't have a host, a physical host behind router B at the moment. It's harder to test access lists with things like DNS and other protocols, but the main thing is to learn the syntax so you can configure the access lists. Welcome to our named access list lab. This time exactly the same setup as before, the same IP addresses. We're going to do a named access list. So conft is IP access list. If you hit the question mark there, it'll say, do you want standard or extended? Let's do an extended access list. The next thing we need to do is give it a name. So let's call it block ping. So this is the handy thing about having names, really. You can say what the access list does. So it's exactly the same syntax now as extended access list. Do we want to permit or deny? Well, we're going to deny pings from the 192.168.1.2 address. So deny TCP, UDP, OSPF. We're denying ping, which uses ICMP. This time it's obviously from, so do we want it from a host or from a network or anywhere? Let's deny ICMP, this time from host 192.168.1.2. So we're only denying it from one host, just so we can get used to the configuration. Deny ICMP from host 192.168.1.2. Do we want to deny it to a network or a host or anything like that? Well, let's deny it to our loopback network. So it's going to be 172.16 and then 0.0.255.255. So anything that starts with 172.16 is going to be matched on the access list. enter, and then basically we need to permit all of the traffic. So permit IP any. We'll exit out of this, and then we need to interface serial 0/0/0 IP access group name or number. Well, it's block ping without space in. So we've created the access list and we've applied it to the interface. We go to router B now. I should be able to ping 192.168.1.1. Fine. I shouldn't be able to ping 172.16.1.1. I forgot to type ping. Control Shift 6X. Ping 172.16.1.1. There you go, it's been blocked. But we're not blocking Telnet, so as you saw in the mistake I made, accidentally on purpose, port 23 for Telnet is open, so you can Telnet across. Go back to router A. Show IP access lists, and you can see we've got block ping working, and that we've had matches on 9 matches on permit everything, 5 matches on deny ping from the 192.168.1.2 network. So have a play, do some more access lists, permit stuff, deny stuff, permit Telnet to your loopback but deny it to your serial. Harder to do a few of the things like denying HTTP, only because it's difficult to test it. But if you've got a host that you can put behind the network, so you can try and connect and open up a web browser, then you can test HTTP and FTP and stuff like that.